Nobody has a monopoly on what is a very hard problem, but I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society.
In this video we compare plane routes on a globe and flat Earth. Let's try to book a flight from Australia to Argentina. The distance between the two places is around 12,700 kilometers. The average cruising speed of a Boeing is around 800 kilometers per hour. That means a non-stop flight should take around 16 hours. It's impossible to find non-stop flights. All the flights go through San Francisco, Houston and Los Angeles. The fastest route we can find takes us almost 35 hours. This doesn't make much sense. Let's see how it looks on the flat Earth map. Let's try from Australia to South Africa. The distance is around 10,000 kilometers. After a long search we found one non-stop flight. Flight time 14 hours and 20 minutes. When we try to book the flight time changes to 19 hours and 30 minutes with one stop. The fastest we can get there seems to be around 20 hours, with one stop in Singapore. Online flight trackers never show planes above the oceans in the southern hemisphere. Why?
His flight path starts in the middle of nowhere. That's because what they do with flights in the southern hemisphere is they disappear them. They turn off the GPS over the ocean, and then they reappear the flights about an hour before landing. And that's exactly what the Flat Earth guys said they do. And that's exactly what they're doing. That's exactly what they're doing. So I just clicked on this flight, same thing. This guy, we should have saw him before when we were tracking the other plane. And when we were tracking this plane that's heading to Rome. But this guy, when we were tracking the plane headed to Rome, he wasn't even on the map. He's coming from Abu Dhabi. It's in the Middle East. He's been in the air for what, 12, 13, 14, 15 hours? He's been in the air for 7,000 miles, and we're just picking him up right here. We're just picking him up in the middle of nowhere. Look.
Flight trackers combine data from several data sources. The primary technology that flight trackers use is called ADS-B.
Dr. D's friend, Mr. Gunnell, works at NASA Langley Research Center. He develops new instruments for global positioning systems and has agreed to meet with us.
Hi, Tony.
If anyone can help us learn more about GPS, he can.
Pretty good. GPS, or Global Positioning System, is a constellation system of 29 Earth-orbiting satellites that were originally designed by the U.S. military in the 1970s as a navigation system.
29 sounds like a lot of satellites.
Why do you need so many?
It takes 24 satellites to provide global coverage, leaving 5 spares. The orbits are arranged so that at any given time, anywhere on Earth, there are at least 4 satellites visible.
Why do 4 satellites need to be visible?
Your GPS receiver needs 4 satellites in order to determine its own location.
How does our GPS locate itself?
By using a simple mathematical principle called trilateration.
I'm not sure simple and trilateration should be used in the same sentence.
What is trilateration?
It's kind of tricky to explain in 3-dimensional space, so let's start with a 2-dimensional example. Let's say you're totally lost somewhere in the US and your GPS is not working.
Like us, yesterday when we couldn't find our geocache.
As you are trying to find where you are, a friendly person tells you that you are 1,000 kilometers from Boise, Idaho. Do you know where you are?
No, I could be 1,000 kilometers in any direction from Boise.
Exactly. Now let's say another friendly person comes by and tells you that you're 1,110 kilometers from Minneapolis, Minnesota. Do you know where you are?
Not yet, but I'm getting closer to my location.
That's right. Now you have 2 choices, but you still don't know where you are. Finally, another friendly person informs you that you are 990 kilometers from Tucson, Arizona. Now do you know where you are?
It looks like I'm in Denver, Colorado. Which, of course, I will be soon.
The same concept works in 3-dimensional space, but instead of circles, you need to think in terms of spheres.
And the satellites are the friendly people telling you how far you are from a place.
That's right. If you know your distance from satellite A, you could be anywhere on a huge imaginary sphere at that radius. If you know your distance from satellite B, you can overlap the first sphere with the second sphere, and they intersect in a perfect circle.
So if you know the distance to a 3rd satellite, you get a 3rd sphere which intersects with the circle at 2 points.
Very good. And the Earth acts as the 4th sphere, so you can eliminate the point in space because you're on Earth.
So do you only need 3 satellites?
An approximate position can be found with 3 satellites, but to improve accuracy and get precise altitude information, 4 or more are better.
How do GPS receivers know how far they are from the satellite?
They analyze the high-frequency, low-powered radio signals from the GPS satellites and calculate the time the signal traveled.
Do satellites have stopwatches?
No, the satellites need to be more accurate than a stopwatch. The satellites use a very accurate atomic clock, which produces exact time-coded signals.
And what happens if a satellite malfunctions?
It's possible. Again, that's why we have 29 satellites when only 24 are needed, leaving a few spares.
It helps to have extra.
True. Here at NASA, we use GPS to determine the position of aircraft and satellites. And we also are developing a system to perform remote sensing of the environment. All of these tasks require precision information. Spare satellites make sure we get the data we need.
Cool. NASA's always doing amazing things.
Mr. Gano, what would happen if your GPS was only receiving a signal from 1 or 2 satellites? Would you get incorrect results?
No. Usually, your GPS device will let you know that it doesn't have enough satellites to calculate an accurate position.
Sounds like we need to do some more research.
Thanks, Mr. Gano.
You're welcome, and good luck with your geocaching.
They've been talking down new sources of energy. They dismiss wind power. They dismiss solar power. They make jokes about biofuels. They were against raising fuel standards. I guess they like gas guzzlers. They think that's good for our future. We're trying to move towards the future. They want to be stuck in the past. And we've heard this kind of thinking before. Let me tell you something. If some of these folks were around when Columbus set sail, they must have been founding members of the Flat Earth Society. They would not have believed that the world was round.